You can see the objectives on the board today are all about cooking. Okay, we've kind of been skirting around the idea of growing food and what it takes to grow food. Today we're going to talk about what it takes to cook food, and our objectives are to be able to list some reasons why we cook food. There's some obvious ones and then there's some less obvious ones, and then giving examples of how cooking food changes it. And then finally, to be able to describe some different ways to cook food. So, to begin with, the three primary reasons, so the main reasons that we cook food are to make it safe to eat. So we know that cooking things can help get rid of bacteria and things like that that can cause you harm if they get into your body. So we mostly cook our food to make it safe. But even if you knew for 100% sure that there was nothing dangerous in a raw egg, would you want to eat a raw egg? Yeah, me neither. And that's because of the other two reasons, texture and taste. Okay, raw eggs do not have much in terms of taste, and their texture is nasty. Nobody wants to put that in their mouth. Okay, so sometimes we cook foods because it helps to change their texture into something that's palatable. And then also cooking food sometimes brings out different flavor profiles, which then make it more pleasant to consume. Because we all need to eat to live, but we are fortunate enough that we live in a part of the world where our needs are mostly met, so we can eat what we want to eat and enjoy what we eat instead of just eating to survive. There are several things that happen when you cook food besides making it pleasant to eat. This includes things like changing its appearance. So when you cook an egg, what happens to the appearance of the egg?
It depends if we're making scrambled eggs.
That's true. Depends if we're scrambling the eggs or just frying the eggs. If we fry the eggs, the yolk doesn't change appearance very much, but the white of the egg goes from being translucent-y clear to being white, right? So we can change the appearance of the food we eat. Lots of foods change color when you cook them. If you've ever cooked a steak, you know it goes from being red to brown, okay? When you pop popcorn, it goes from being either a brown or yellow color on the outside to being white and puffy, and it changes its color completely. Peas, if you heat up a lot of green vegetables and you cook them, you'll notice that the color of them changes. At first, what happens is you remove water from them, which makes them appear brighter in color. So if you've ever cooked broccoli, you'll notice that at first, the broccoli actually appears more green after it's cooked than it did before you cooked it. And that's because a lot of water leaves the cells, and that water is no longer causing light to bend, so the color of the chlorophyll stands out more. But if you overcook vegetables, especially green vegetables, you'll notice that they go from being green and bright green to being more of a brownish green. And what's happening there is the pigment, the chlorophyll that's in them, is actually being broken down. And so as a result, they lose a little bit of that color. So if you've ever had overcooked peas or overcooked broccoli that's very mushy, you'll also notice that it's not quite as bright green as other broccoli. Another change that can happen is a loss of nutrients. This is not true for all food, but for some foods, when you cook them, they lose some of the nutrients in them. For example, there are many vegetables that have vitamins in them that are important for your life. However, those vitamins are what we call water soluble. Water soluble means that those vitamins dissolve in water. So what happens when you start cooking your canned peas on the stove is that the vitamins that are in those peas can dissolve into the water around them, and then when you drain your peas before you go to eat them, all those vitamins get washed off. And so as a result, then we lose nutrients from the food. Now, this is not always the case. For example, carrots have a vitamin in them called vitamin A that is fat soluble, which means it won't dissolve in water. It will only dissolve in a fat. So carrots, when you cook them, don't lose their vitamins, at least not vitamin A. So this is a reason why it is not a bad thing to eat lots of cooked vegetables, but it's also a good idea to include some raw vegetables in your diet, because you may get some foods or some vitamins that you wouldn't be able to get in the cooked version of them. It also can cause it to produce something because it goes through a chemical reaction. So some of the processes of cooking don't just break things down, but they can also cause chemical reactions to happen, which can form new products. Okay, for example, when you mix water in with flour, because let's say you're making a bread dough, and you start to mix that together, the water softens the carbohydrates, which lets them stick together, and the process of those carbohydrates sticking together forms a new product called gluten. Gluten is what gives dough its elasticity. So if you can stretch that dough, it probably has lots of gluten in it. In fact, bread makers do this thing called the window pane test, where they decide if there's enough gluten in their bread by trying to stretch the dough out enough that it forms a thin membrane that you can see through. And they say if you can do that without the bread dough ripping, then you have enough gluten in your bread. Okay. Another thing that could happen is if you're making a yeasted dough and you add yeast and sugar to your dough. Yeast is a little microorganism, and it eats the sugar, and while it's digesting the sugar, a product of that is ethyl alcohol and carbon dioxide. So those things, that carbon dioxide that's produced then while you're baking your bread, causes the bread to rise, and you get those air pockets in your dough. So the food that you get at the end comes out being totally different than the products you began with, because of these reactions that take place because of that gluten formation and because of the carbon dioxide being produced in the bread by the yeast. So you wind up with bread instead of just flour, water, yeast, and sugar, which probably wouldn't taste bad together, but certainly don't taste as good as bread does. Yet another thing that can happen is that the proteins in the food that you're cooking can become altered or changed. Okay? So you may have noticed that uncooked ground beef or uncooked steak has a red color to it. And that's because there are molecules in the meat that have iron in them, and that iron has oxygen attached to it. And as a result, it causes that reddish color that we're used to in meats. But at high temperatures, that iron loses an electron, and as a result of losing the electron, it can't hold on to that oxygen anymore. And so it has to let the oxygen go. And letting go of the oxygen causes it to change color from being reddish to being much more brown, which is why when you cook hamburger or you cook a steak, you wind up with brown color. Heat also causes the amino acids in meat to uncoil. We call that denaturing. So if you denature a protein, you're causing it to uncoil. Okay? And this allows those proteins that are uncoiled now to stack much better, and they condense and they force water out of the meat. So forcing water out of the meat changes the texture, and it also changes the color of the meat. And lastly, you all have connective fibers in meats. You have connective fibers too, because you are meat as well. So if you've ever pulled the skin on the back of your hand, you'll notice that not only is it stretchy and elasticy, but it doesn't tear apart when you do that, right? And that's because you have connective fibers connecting the meat that is your hand, okay? And when those connective fibers are heated up, they start to break down. And this happens especially if you cook them over really long periods of time at low heat, which is why if you have a tough meat that has lots of connective fibers in it, you cook it low and slow for a long period of time and the meat comes out much more tender. So if you've ever put a roast in the crock pot for like 8 hours, or if your dad has smoked something on the grill for like 6 hours, what they're trying to do is take a tough cut of meat because of all those connective fibers and make it more tender and easy for you to eat. There are also many methods of cooking food. I'm sure you've seen lots of different ways. You know, people boil food, people steam food, but some of the most popular are what we would call conventional methods of cooking. So this would be things like an oven or a grill or a stove top, right? Those are traditional ways that we cook food. And these heat food from the outside in. So what's happening is the food comes into contact with a hot surface like the grill or the stovetop or the pan that it's in that's hot, or sometimes in the oven, if your oven is convection, the hot thing that it's touching is the really hot air. Okay? But what happens is that cells that are on the outside of the food get hot, and then because they're touching other cells on the inside, those cells get hot, and slowly but surely the heat makes its way from the outside to the inside of the food. Other less conventional methods of cooking are pressure cooking. Now, pressure cooking has become more popular now than it used to be because of the introduction of the Instapot. Okay, it used to be that if you were using a pressure cooker, what you were using was a canner. So some bacteria that grow in food can only be killed at really high temperatures. And this is especially true of some vegetables that you might try to can, like for example, pumpkin. Pumpkin's not very acidic, and so it doesn't kill bacteria that way. So you have to get it to a really high temperature if you want to kill off the bacteria. But the temperature that you need to get it to is much higher than what you could get in just an oven or on a stove. So canners and Instant Pots use water and pressure and heat to cook their food, because what happens is if you seal the container so no air can get in or out, and then you crank up that temperature, then the pressure inside the canner increases as well, just like the pressure inside the popcorn kernel increased when we heated it up, except the skin of the popcorn kernel is really weak, and these pressure containers are made out of metal, and so they are very sturdy. So the pressure just keeps going up and up and up. And one thing that we understand as scientists about temperature and pressure is that they are connected. So as pressure increases, the temperature also increases. So you're able to reach temperatures much higher inside a pressure cooker than you are inside just like a regular oven. So they are able to cook things much faster and also to much higher temperatures, which is why if you've ever cooked chicken in your Instapot, you know it doesn't take anywhere near as long as if you tried to boil the chicken on the stove, because the pressure allows the temperature to get much higher and it cooks it much faster. The other method of cooking that has become much more common, so I found this funny when I was writing these notes, but our book seemed to treat this as new technology, and that is microwave cooking. Now we all cook in our microwaves, right? But when our book was written, it wasn't quite as common, okay? So what microwaves do is they send out what's called microwave radiation. It's a type of electromagnetic radiation, and it penetrates food. So microwaves can pass through things, which is why if you've ever noticed the glass screen on the front of your microwave has like a mesh that goes over it that has little holes in it so you can see your food, but it's not just clear glass. And that's because that mesh is there to stop the microwaves from getting out of your microwave. Okay? And what they do is they penetrate food and they cause the water molecules that are inside the food to vibrate. And when those water molecules vibrate fast enough, they create friction with the neighboring molecules, which produces heat. Like if you've ever rubbed your hands together really fast, you notice your hands get warm, right? The same thing happens when these particles vibrate really fast. So as a result, microwaves actually cook food from the inside out. So whereas when you put something on the stove, it cooks outside in. When you put it in the microwave, it cooks from the inside out, which is how you can have like say a pizza roll that you cooked that on the outside you can touch it and then you bite into it and it's like boiling lava in your mouth, right? It's because it's hotter inside because it cooked from the inside to the outside. But microwaves can interfere with each other when they run into each other, which can cause cold spots and hot spots in your microwave, which is why you will notice that most microwaves nowadays have a spinning table in the bottom of them that spins your food while it cooks, and that is how they keep it from getting too hot in one place and not hot enough in another. All right, that is the end of our notes for today.